Guys, so today we're going to be looking at how to simplify radicals. So first we'll go ahead and look through the parts of a radical. The little index here is the little n. We're just going to be looking at square roots and these kind of things, and so we're not going to have an index. So we're going to assume that n is 2 when there's not something up there. So like if you have the square root of 4 like that, that's all that means. The radical is the actual symbol around the number, and then the number underneath it is considered the radicand. We're going to list the first 12 perfect squares. So that's just the first 12 numbers times themselves. So first 12 numbers squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and then 12 squared is 144. So that's just 1 times 1, 2 times 2, 3 times 3. Okay, so if you take the square root of each of these, you're going to get a whole number is the point of this. So for instance, if we look at the square root of 16, you're saying what times itself, what squared, gives us 16. Okay, 4 times 4 is 16. The answer is 4. 4 squared, or 4 times itself, gives you 16. Okay, this just means 2 times whatever you get under there. Okay, so 2 times, we can look at the radical on its own. 121, what times itself gives you 121? That would be 11. And then we can just take 2 times 11 and get 22 for our answer here. This again, we'll look at the number on the outside on its own, and then we'll take 289. What times itself gives you 289? If you actually type that into a calculator, you're going to get 17. So 17 times 17 gives you 289. And then if you multiply 6 times 17, you're going to get 102. And then 400 should 20 times 20 is going to give you 400. So since 20 times itself gives you 400, the square root of 400 is 20, then 3 times 20 is just going to give you 60. So this is mainly what we need to focus on, is simplifying these non-perfect square roots. You're not always going to get an exact number, you're going to get a decimal. So first, we're going to start out by taking the number underneath the radical, the radicand, okay? We're going to take this number and we're going to list out its factors until we can find a perfect square, okay? So looking at 32, we have 1 in 32. So 1 times 32 gives you 32. And 2 times 16 gives you 32. And we can go ahead and stop there, okay? Because 16, if we look up on our list of perfect squares, is a perfect square. Okay, so we're going to split this up. We're going to say square root of 2, square root of the first number, times the square root of the second number. Because if we multiply that out, we multiply what's under the radicals together, we will get square root of 32. Now that we've split this up, okay, we know that square root of 2 is still here. We can't do anything with it. But we can multiply by square root of 16, which is actually 4, okay? And then we're going to put that in front of that to make it a little neater so that it doesn't look like the 4 is underneath the square root. So you write out the factors of the number underneath the radical until you actually find a perfect square. Then you're going to take the square root of the perfect square and take it out of the radical. And you're going to leave the leftover, or whatever's left, underneath the radical. So if we look at number 6 here, we're looking at 180. Factors of 180 are 1 and 180. 2 and 90, none of those are perfect squares. 3 and 60. 4 and 45, still not perfect squares. And 5 and 36, but we can stop there because 36 is a perfect square. So we're going to split this up. I'm going to do it this way this time so we don't have to flip them back and forth. So square root of 180 is the same as square root of 36 times the square root of 5. we're going to take the square root of this one, simplify this, so square root of 36 is the same as 6, and then we leave the square root of 5 underneath the square root under, right there. And that's our answer. So we write out the factors until we find a perfect square. We take the square root of that perfect square into there after we split it up, and then we leave the leftover underneath the radical. So if we look at 147, we have 1 and 147, 3 and 49. Luckily, 49 works out. So we keep the square root of 49 and square root of 3 here. Okay, because 147 is the same as 49 times 3, so you can split that up, showing that the radical 147 is equal to radical 49 times radical 3. Okay, square root of 147, or square root of 49 is 7 times the square root of 3. Okay, and just leave it like that. 175, we have 175 times 1, and then we have 25 times 7. 25 is a perfect square. So we're going to split this up into square root of 25 times square root of 7. Square root of 25 is 5, and we're going to leave the square root of 7 underneath the square root. So just leave it how it is, sorry. 48, we have 1 times 48, 2 times 24. Still not a perfect square, but we do have 3 times 16, and 16 is a perfect square. So, square root of 16 times the square root of 3 will give us the square root of 48. Square root of 16 is 4. We still need the square root of 3 there. That's our answer. This one, whatever we split it up into, we're going to keep this 2 on the outside, and we're still just going to look at the number underneath the square root. So we have 54 and 1, 27 and 2, 18 and 3, and then we have 9 and 6. And 9 is a perfect square. So we can do it square root of 9 times the square root of 6. If we simplify that, square root of 9 is 3. Okay. We keep the square root of 6 as its own, and then whatever's outside of the square root we can multiply out, and we leave whatever's inside the square root under the square root. So let me know if you have any questions with this. You have practice problems on this to work on tomorrow. Let me know any questions, and I hope you guys understood everything. Have a great day.